Welcome. In this video, I'll show you how to design, customize, and 3D print your own planetary gear system using OpenSCAD. We'll dive into the parameters that allow you to create the perfect gear set for your needs, whether it's for a robotics project, a car transmission, or any application that needs high torque and a compact design. Plus, I'll walk you through where to download the OpenSCAD file and the software itself to get started. First, let's talk about where to get everything you need. To download OpenSCAD, head over to OpenSCAD.org. It's a free, open-source software that's perfect for creating parametric models like this one. You can find the Planetary Gear OpenSCAD file on the page linked in the description below, ready for you to download and start customizing right away. Now, let's talk about how planetary gears work. In a planetary gear system, the sun gear sits at the center, surrounded by planet gears that mesh with both the sun and the outer ring gear. This setup provides high torque in a compact form and helps distribute the load evenly, making it ideal for applications like robotics, machinery, and automotive systems. So, how do you customize these gears? Well, the OpenSCAD model is fully parametric, meaning you can adjust the design to meet your exact specifications by changing a set of simple parameters. Let's break them down. Module, this sets the size of the gear teeth. It's a key design parameter that determines the overall size and strength of the gears. A larger module means bigger, stronger teeth, which is great for high-torque applications. Solar teeth, this defines how many teeth the central sun gear will have. The number of teeth impacts the gear ratio, which in turn affects how torque and speed are transferred through the system. Planet teeth, this sets the number of teeth on each of the planet gears. The planet gears mesh with both the sun and the ring gear, and this value also influences the gear ratio. Number of planets, you can adjust how many planet gears are in your system. Adding more planets helps distribute the load evenly across the gears, which increases the torque capacity and makes the system more durable. Width, this defines the thickness of the gears along their axis. Thicker gears are stronger and more robust, especially when the system is under heavy load. Pressure angle, this is the angle between the line of action and the tangent to the pitch circle. A higher pressure angle increases tooth strength, while a lower angle leads to smoother motion, though with less strength. Helix angle, for helical gears, this defines the angle of the gear teeth. A higher helix angle results in smoother and quieter operation, though it introduces more axial thrust. Clearance, this sets the gap between the top of one gear tooth and the bottom of the mating tooth. It's necessary to ensure smooth operation and to account for thermal expansion and manufacturing tolerances. Rim width, this defines the thickness of the gear rim surrounding the teeth. It affects the structural integrity of the gear and helps prevent deformation under high loads. Detail, this parameter controls the level of detail in the model. A higher detail setting means smoother curves and a more precise model, but it also takes more processing power to render. Once you've customized the parameters to your liking, press F6 in OpenSCAD to render the design. Then, export the model as an STL file by going to File then Export as STL. After that, you can import the STL file into your slicing software, adjust the print settings, and get it ready to 3D print. For most applications, PLA is a great material to start with, but for more strength, you might want to try materials like PETG. With the OpenSCAD file, you have full control over your planetary gear design. Whether you're making a functional prototype or just experimenting with new ideas, this parametric design makes it easy to create exactly what you need for your project. Happy designing and printing!